Hi, in this video I'm going to show you how to code multiple response items. To facilitate my demonstration, I'm using a new dataset which is independent of the more complete dataset that I used in previous videos. In this dataset, I have only one question, which is called Q1, and there are three options to be selected under Q1. The respondent can select more than one option. If you collect your data using Google Form, then your multiple response data will look like the following. It shows the options that are selected by each of the respondents. So for example, in case 1 here, the respondent has selected all the three options, so all the three options are here put together in this cell separated by commas. If you try to plot the frequency table of this data by clicking on the Run Descriptive Statistics, you get a frequency table, but this is not what you really want because this frequency table gives you the frequency to each of the combination of the options in your dataset. What you need instead is a frequency table with frequencies to each of the individual options. For example, how many people choose option 1, how many people choose option 2, and how many choose option 3. The key to do that is to recode your original data into separate variables on the right, and each of the columns or variables here represent one option of your multiple response item. Now I have 3 options here, so I have 3 variables. If you have 10 options, then you have to make 10 variables. In each of these variables, you see that we only have either 1 or 0 in the data. And 1 means that the option has been selected, and 0 means that the option has not been selected. For case 2 here, we have 1 here, 1 here, but 0 here under option 3 because option 3 has not been selected. It is very simple conceptually, but the problem is how to actually do this kind of data conversion from the original data to the separate variables. Of course, you can input everything by hand, but that will be a tedious task if you have a large sample set. But fortunately, there is a way in SPSS to complete this kind of task more quickly. And I'm going to tell you how. To do the data conversion, we click on Transform and then Compute Variable. Compute variable allows you to use some formulas to manipulate the data in the variables. And in this case, the first thing to do is to provide a name of the target variable. Again, it is a new name. I type q1 dot option 1. On the right, we have to type index. Index is the name of a built-in function of SPSS, much like the built-in functions in Microsoft Excel. And index here means to look for something from Q1 here. So we double click on Q1 so that Q1 goes to the right. And then we type a comma. Now we type a double quotation mark and then option 1. Here you need to use the exact wordings that you use in your option. So for example, in the option here we have a capital O, so here we also need to use capital O. We have a white space between the option and 1, so here we want to have a white space between option and 1, and then close bracket. This is not yet correct, but I want to click OK here to show you the result first. OK here. In the first 3 cells, you have a 1 here because option 1 is selected by the respondents of these 3 cases. And then in cases 4 and 5, you have 0 because option 1 is not here. Let's do it again for option 2. Now this time we can click on the Recall Recently Used dialogs and then click Compute Variable. Now this time I give it a new name, which is q1 dot option 2. And then on the right, change the option 1 to option 2, and then click OK. There's something wrong this time. Here, I would expect 1 here and 1 here. I suppose 1 means that the option has been selected, but instead it gives you an 11. 11 here actually shows you exactly what the function index is doing. What the function index does is not to tell you whether the option is selected or not. Actually, it tries to look at the data here and look for option 2. And then if it finds option 2, it gives you the location of the first character of option 2. And in this case, it is the capital O. The capital O is the 11th character in the whole string. And the same is true for the second case. Option 2 starts at position 11. In the third case, we have 0 because option 2 is not found. If it doesn't find anything, then it gives you the position 0 because nothing can be put at position 0. So if you see 0 here, it means that it is not found. And for cases 4 and 5, you get a 1 here because option 2 starts at position 1. But the problem is that we don't really need the position. We only need a 1 here. So let's go back to the compute variable to fix the problem. Now the key to fix the problem is also very simple. Now what we do is to add the greater than symbol and then 0. In this case, when the index function tries to look for option 2 from the data in question 1, if it doesn't find any, then it gives you a 0. 0, of course, is not greater than 0. So the whole statement will evaluate to false. And false in SPSS is represented by 0. On the other hand, if it finds something, for example, it finds option 2 in the position 11 of the string, then it gives you 11 here. And of course, 11 is greater than 0. So the whole statement evaluates to true. And true in SPSS is represented by 1. Click OK. Allow it to change the existing variable. So the problem is fixed. This time, case 1, case 2 give you a 1 instead of 11. Let's fix the problem for option 1. Go back to q1.option1, change it to option 1, keep the greater than 0 at the end. Click OK. Allow it to change the existing variable. Let's do it again for option 3. And then click OK. This is how you recode the variable. But the next question to ask is, now we have the recode variables, then how can we analyze the data? For this kind of data, actually it is nominal level data because they are not numbers, they are not particular orders to follow. In this case, what we usually do is to show the frequency table or frequency distribution of these different options. But if you simply generate the frequency table of these new variables, then what you get is not one single table, but instead 3 separate frequency tables. And of course, this is not what we are expecting. What we want is a single table with all the 3 options together. I just want to know how many people have selected each of the options. I'm not interested in knowing how many people have not selected each option. We want to look at the 1 here, but we are not interested in the zeros here. In SPSS, there is the particular function to handle this kind of situation, and you can find it under Analyze and then Multiple Response. Click on it and then choose Define Variable Sets. Now here you should put all the options into the box in the middle, and down here next to the counted value, we put a 1 here. The 1 here means that in our data, we use 1 to represent the case in which the option is selected. So we need to let SPSS know that the number 1 here is important. So we put a 1 here, and then in the name here, we put a q1.recode. This is simply the name that represents this question. Click Add so that it becomes a multiple response set. Click Close here. Nothing has changed, but if we click on the Analyze again and then Multiple Response, now this time you can click Frequencies and you see the multiple response set here. Put it to the right. If you have other multiple response sets, you can also put them to the right. You don't have to do this one by one. Now we click OK. Here is what you get. A single table which shows each of the options and the frequency of each of the options put together. Here the 10 is simply the total of these frequencies, and we have also the percentage. The 30% here is simply 3 divided by the total. But notice that in my case, I have only 5 respondents, or in other words, my sample size is 5. But because each respondent can choose more than one answer in this question, so the total number of responses add up to 10, which is larger than the sample size. But the percent here, in my opinion, is not very useful because it simply gives you the frequency divided by the total response. But the total response here, the number 10 here, is not particularly meaningful in this situation. On the other hand, the more useful percentage data is the percent of cases on the right. And the 60% here is the frequency divided by sample size. In this case, it is 3 divided by 5, gives you 60%. The meaning of 60% is that out of my respondents, 60% of them have selected option 1. This is more meaningful than the percent of responses. If you check these percentages for option 2, you can say that 80% of my respondents have selected option 2. So it seems that option 2 is quite popular among our respondents. Option 1 is also popular, but not as popular as option 2. Option 3 has the same popularity as option 1. And again, these 3 percentages add up to more than 100% because it is multiple response item. This is how you analyze multiple response data. I hope you find it helpful. Thank you for watching and see you next time.